So in this video, we're going to be discussing quantum development of the atom, starting with the Bohr model of the atom. There was a problem at the time as they were investigating these emission spectrums from the atoms. And down here I have hydrogen's known emission spectrum. You've got these two violet lines, and you've got a cyan, and you've got a red around 650 nanometers. The problem was that scientists assumed and hypothesized that these atoms should be emitting light of all colors. There should be white light coming from them. So why in the world was it these specific frequencies, and why did every frequency vary with every atom? Because even if an element emitted red, it wasn't the same red photons that were coming off of the hydrogen atom. They were different photons coming off. This is a major problem, and in order to discuss that problem, we got to talk about how electrons are arranged. Excited and ground state electrons, what Niels Bohr did was he placed the electrons on energy levels. These energy levels are also known as shells. And these shells have specific energy values that we'll see here in a little bit. The electron on the lowest possible level is called a ground state electron. And so here I have an electron spinning around at the lowest level it could possibly be at. Whereas an electron on a higher level than it could be on is called an excited state electron. So here I have an electron now spinning around on an excited state level. It could be one shell lower. And the difference between those is the electron on this shell 2 has more energy than the electron on shell 1. So here's how Niels Bohr decided that atoms are emitting these lights. The idea here is that the electrons can't just be anywhere in the atom. They have to be on these discrete energy levels. Discrete meaning extremely well defined. They're not just in any spots. So I can't have an electron between these two white lines here, between these two white lines. They have to be on these specific orbitals, as they're called, about the nucleus. So what I always do is I have people watch this first, and then we write down what happens. So when atoms are emitting light, the first thing that they have to do is they have to absorb some kind of energy. So in the demonstrations in class, when I had the emission tubes, so what we did is we put them in that high voltage source, and then we turn the source on, and the electrons were energized, and the electrons in the atoms that were in there went to excited states. So the electron absorbs a photon, goes to an excited state. So here comes a photon, and it's absorbed by the electron, and it goes up to state 3. Now the electron does not like to be in excited states. They want to be on their lowest potential energy that they can. So the electron's not going to orbit for very long before it re-emits that photon, and it's going to fall back down to the ground state. And in order to do that, it has to emit a photon. So the electron can fall to any lower level, but it has to emit a photon each time. In this case, I had the electron falling from shell 3 to shell 1. So we back this up. The electron has to absorb energy. So here's the electron coming in. It absorbs the energy. The electron goes from shell 1 to shell 3. The electron doesn't like to be there, and it's going to fall back down, emitting a photon. Now this last statement, the electron can fall to any lower one. Well, it could have fallen from shell 3 to shell 2, as we're going to see on this next one. This time I've assigned arbitrary energy units. These aren't the real energy values. They're just numbers I made up. And we're going to call the energy of the ground state 0, and the next energy level is 10 energy units, and the next one is 15 energy units. So here I have a photon coming in, and it's purposefully yellow light, and it absorbs energy. How much energy does it absorb? Well, it started on 0 and went up to 15, so it absorbed 15 energy units, and that was equivalent to yellow light. So if it's going to fall from shell 3 to shell 2, it has to emit light. How much light does it emit? Well, it's got to go from 15 to 10, so it has to emit 5 units of energy. Well, how much is 5 units of energy, relative to yellow? If yellow was 15, 5 units of energy is going to be lower amount of energy, so this is probably going to be a red photon. So as you watch the electron fall from shell 3 to shell 2, I emit a red electron, and there it goes. I'm sorry, I emit a red photon, and there it goes. But again, the electron is not on the ground state, so it still wants to release more energy, emit more energy, and so it's going to fall again. This time it's going to go from shell 2 to shell 1. Well, this time it has to emit 10 units of energy. Well, 15 units of energy was yellow light and 5 units is red light, then this energy must be orange light. And so there goes my orange photon, and now you can see how the atom is emitting these lights. What Niels Bohr did was he put these electrons on discrete shells. So the Rutherford model, the electrons could be anywhere around there, which is why scientists thought that as these electrons absorbed and emitted energy, they could absorb and emit energy from anywhere. Bohr said, nope, that's not the case. They have to be on discrete energy levels, they being the electrons, and they can only absorb so much. In the example I just gave, if that energy on this slide right here, if this energy coming in go all the way back to the beginning here. If this energy coming in was not exactly 15 units, nothing happens. If it's 13 units, nothing happens. If it's 17 units, nothing happens. It has to be exactly 15 units in order for this to happen. So this is the Niels Bohr model of the atom. Now this is three-dimensional, not two-dimensional. They're not orbits like planets. They're three-dimensional, let's call them spheres for right now, spherical shells. Zooming about the nucleus. So this is a better picture that explains the emission spectrum of the atoms. But there's other problems. First of all, this only explained the hydrogen atom. He couldn't do the calculations and figure out the helium atoms or anything else like that. So he needed more development in